In these problems, we're being asked to find higher order derivatives and of linear combinations of power functions. So functions similar to the ones we've been taking the derivative of. So what is a higher order derivative? Well, if you have a function f of x, the derivative, if we take the derivative, we'd call that f prime of x, or in that other notation, uh, df dx or ddx of f of x. So that's the derivative. If you go ahead and take the derivative of that, the derivative of the derivative, you'd get what's called the second derivative. And we might write that as f double prime of x. Why would we want to do that? Well, for a lot of functions, the derivative and the higher order derivatives have some significant meanings. So if you have a function that's maybe showing the position of something, maybe this is the position of a spacecraft relative to the Earth over time, well, you know that the derivative of this function is the rate of change. So the rate of change of a position is a speed. So the derivative is speed. If you take the derivative of the derivative, that'd be the rate of change of speed. That's actually acceleration. So first derivative of speed, second derivative acceleration. Actually, if you take the derivative of that, you get the rate at which your acceleration is changing. Sometimes we call that jerk. And if there are non-zero values for the third order derivative, you realize you're going to get a bumpy ride. So there are meanings behind these higher order derivatives. So often we need to take them for practical purposes. In this case, we're being asked to find g double prime of z, so the second derivative of, of this function g of z. And this shouldn't be too hard. We're just going to apply the power rules that we know and then do it again. So let's get g prime of z first. So we're going to take 5 times z, reduce the power by 1, 5z to the fourth, plus 2 times 4 is 8, z, and then minus 7z, that's just going to be minus 7, because z to the first you'd multiply by 1, and then that z would go down to 0, so it just becomes 7. So there's the first derivative, and then we'll just repeat the process to get the second derivative. So 5 times 4 would be 20, and then that'd be z to the third, and then this would be 8, and that's it. One of the nice things about taking higher order derivatives is that they get actually simpler the longer you go. The powers decrease and the number of terms tend to drop away. So we ended up with 2 terms when we started with 3. Let's try another. All right, so here we've got 6t squared plus 4t plus t to the negative third, and we want the second derivative, f double prime of t. So let's find the derivative first. So that'd be 2 times 6 is 12, and that'd be t to the first, and then plus 4, because that's t to the first, and then it goes to the 0, so it disappears. And then we got t to the negative 3, so that's minus 3t to the negative 4. Now, when we do the second derivative, this 12t just becomes a 12. The 4 goes to 0, so I'm not even going to write it. The derivative of constant is always 0. And then we've got negative 4 times negative 3, that's plus 12t to the negative fifth. I think I've got one more here. Yeah. So this is just a reminder that when you've got fractions with the variable in the denominator, when you've got square root symbols, you want to rewrite these as powers. So I'm going to write this as x to the 1/2. That's the same thing as the square root of x plus x to the negative fifth. And this time we want to find g triple prime, so the third derivative of g. So let's do this. So 1/2 times, let's just carefully write this down. We're going to find the first derivative first. So 1/2 x to the negative 1/2 minus 5 x to the minus 6. So that's the first step. Let's try the second derivative. Now we've got a negative 1/2 times a positive 1/2, so it's a negative 1/4 times x to the negative 3/2. And this is plus negative 6 times negative 5, 30 x to the negative 7th. And now we do it one more time to get the third derivative, g triple prime. So negative 3/2 times a negative 1/4, that's going to be a positive 3/8 x to the negative 5/2. And then we're going to have 30 times 7, so negative 210 x to the negative 1/8. All right, so that is some work with finding higher order derivatives.